The dress is a photograph that became a viral phenomenon on the internet in 2015. Viewers of the image disagreed on whether the dress depicted was colored black, blue, or white gold. The phenomenon revealed a difference in human color perception, and for the first time, people were actually curious about color. But how did this all happen? Well, in order to answer that question, we have to go back to the time when child is born. When child is born, it cannot see color. It can detect light and dark. Gradually, over the first week or so, the photoreceptors, or commonly known as the color detectors, become tuned by a process that is random and accidental, by a cell responding to light. Firstly, we have to understand that we have got 3 set of cone cells in our eyes with sensitivities in the blue, green, and red color, often designated as S, M, and L for their sensitivity to short, medium, and long wavelength. What are cones, you may ask? Cones are basically a medium through which we see light or colors. Each has a specific chemical, a photopsin, that reacts to light of a particular frequency range and sends signal to the brain. If one set of cone does not function, dichromatism results. We'll talk about it more in a second. So, in theory, each eye is the same. Light enters the eye through cornea and iris, then focuses on the back of the inside wall of the fovea, which is the exact point in the center of what you look at any given point or any given second, where the highest concentration of color sensing cells, the cones, and some light and dark sensing cells, the rods, are present. But that's a different thing though. That's a different topic altogether. But unfortunately, many people have only 2 kinds of cones cells in their eyes, and these people are often called dichromats, or commonly known as colorblind. Colorblindness affects around 8% of men and half of 1% of women. Dichromacy results when a genetically mutant red or green photopigment gene on the X chromosome fails to express its retinal photopigment. Colorblind people don't see things in black and white, they just have trouble telling the difference between red and green. Both could sort of look like brown to them. For instance, someone with a good color vision would see the visual spectrum like this. But someone with an anomalous color vision would see the same visual spectrum more like this. You can see the primary colors are exactly the same. As the color ability declines, it is a transition between the primaries that suffer. For instance, they will see just a darker form of blue instead of purple and gray instead of turquoise. This is because the color is just at the point where both the green and blue sensors are quite weak. Color blindness or color vision deficiency is the decreased ability to see color or differentiate in color. It can impair tasks such as selecting fruits, choosing clothes, or even reading different traffic lights. However, issues are generally minor, and the colorblind automatically develops adaptations and coping mechanisms. The 3 most common types of color blindness, or you can say color inability or mild color blindness, are protonormally, which is the reduced sensitivity to red light, deuteronormally, which is the reduced sensitivity to green light, and which is the most common form of color blindness, and lastly, tritonormally, which is the reduced sensitivity to blue light, and which is the extremely rare case of color blindness. But on the other end of the scale, some have tetrachromatic visions, meaning 4 colors. They have 4 cone cells in their eyes, which enables them to see up to 100 million colors. Birds and reptiles are a good example of tetrachromatic visions. While we trichromats can see about 1 million colors, to these individuals, it's the rest of us who are colorblind. So even in the worst case, it doesn't really happen that you see yellow and I see red. That's a very rare and special case. What usually happens is that people will see a color that might be a bit reddish or a bit yellowish, which is why most people who have poor color vision never notice they are colorblind. I hope it was a very succinct explanation about colorblindness. Let's move on to how we are able to see color. This small rainbow box in between ultraviolet and infrared rays is the visible light spectrum, meaning all the color is visible to human eyes, which makes about only 5% of total light. All forms of light across the entire light spectrum, which is visible light, gamma rays, X-ray rays, ultraviolet rays, infrared rays, microwaves, etc., are all the same thing, electromagnetic radiation traveling in waves. Different objects made up of different types of matter will absorb and reflect light differently. This all happens very quick, because the light moves extremely quickly, almost 300 meters per second. Take a red apple, for example. The skin of the apple, when viewed in white light, will absorb most frequencies of light and reflect back only red frequencies. Though apple is not red, we have evolved to interpret it as red. Look closer and closer, at the apple skin. Eventually, you will only find atoms. Atoms made up of protons, neutrons, and electrons, none of which are inherently red. Now, you may ask, if I only have green, blue, or red cone cells, how can I see colors like yellow, purple, turquoise, etc.? The thing is, yellow light, for instance, triggers both your red and green cone cells. So when your brain receives somewhat muted signals from both your red and green cone cells, it produces a sensation of seeing yellow perhaps. Light is created by particles or photons moving about in space. These particles can take the form of a wave. As you can see, the flatter the wave, the less energy the light beam has. In other words, colors like red, yellow, orange will have much longer wave because they require less energy compared to colors like blue, violet, which have shorter wavelength, thus requiring more energy. That is, the light beam travels at the speed of light. If it has less energy, it will go up and down less as it moves. All the variation you get in the world, which is blue, green, red, comes from the fact that these line goes up and down quicker or slower as it reflects off textured objects. But that does not mean we see everything in white, black, or gray, because they don't measure the wavelength of light at all, but they measure the lack of quantity of light. So to recap, color is a neurological response to the signals being sent to your brain by your eyeballs, which are stimulated to varying degrees by photons with different wavelength. Now, we talked about how humans are able to perceive colors, but have you ever wondered how screens or any electronic devices are able to reflect colors? In your screen you're looking right now, there are only 3 colors. There is no white or no yellow elements. Your screen cannot make them directly because your screen has only 3 elements: R, G, B, red, green, and blue. And this is how your screen is able to bring out all the other colors humans are able to see. See, where the green light crosses over the red and this intersection makes yellow. That is how the screen is able to do it. All the 3 RGB elements firing at full brightness makes the white, which is the center. And when you make an intersection of red and blue, it will give you magenta. And the screen will reflect off cyan if you mix green and blue together. And when all the RGBs are turned off, the screen will make black. Changing the ratios of intensity of these 3 elements makes all the colors a screen can ever make. This is how your eyes work, but in the reverse way. I was finally able to make this art. It took me about 2 weeks to complete this. As someone who is interested in art, the idea behind colors and how it is reflected on is the basic physics that is taught to you in school. But for me as an artist, it was always curious as how we are able to see different shades of colors within one color, and it was always intriguing. So the idea behind making this art was simple. When light passes through a prism, it reflects back a visible spectrum of light, which is the visible light, and all the variations in color we get to see in this world is basically coming from this light spectrum. But let's keep science aside. I had a really good time making those diamonds. So the dress phenomenon was just an optical illusion that later caused a hysteria among the people on the internet. Put simply, if there is a bright background, objects in the foreground will appear darker. Likewise, if that background is dark, objects in the foreground will appear lighter. Hope you'll leave us some useful insights. Make sure to watch part 2 to know how we are able to detect someone's gaze upon us even without looking at them.